Alright, so today we're going to explore Faraday and his law of induction. In the 19th century, he performed experiments with a wire and a ball magnet. We can show a similar setup here.
In this arrangement, we have a powerful magnet, a copper coil with 100 turns, and an easy-to-read analog ammeter to show the induced current. Faraday's law dictates that a coil exposed to a change in magnetic flux will experience an induced current. As you can see, when we move the coil back and forth through the magnet, there is a measurable induced current as shown by the moving dial. Notice, however, that the dial fluctuates between positive and negative values. This is governed by Lenz's law, which helps us to determine the current's direction with respect to the direction of the changing flux. Simply put, the difference in polarity is due to the fact that the magnet is moving back and forth in a single direction. Here we can see that orientation has no effect on Faraday's law, so no matter whether the magnet or the coil is moving, we have the same induced current.
Now we're going to look into how Faraday's law can be expressed mathematically. To do this, we'll use the vector operator curl. If you haven't heard of curl before, there'll be a link in the end to some further reading and explanation. Coming back to the equation, we see that the left-hand side is the curl of E. This means that the vector operator acts on the electric field E. The right-hand side is the partial differential of B, the magnetic field, with respect to time. Notice the negative sign in front of it, which is a consequence of Lenz's law.
Our understanding of Faraday's law has allowed for the invention of technology that is common in the modern world, including what is probably the most important, electricity generation. Faraday's law allows for the large-scale generation of electricity that is essential to our modern way of life. The same basic concept shown in the experiment is used in power stations to generate electricity for the national grid. These use massive rotating electromagnets surrounded by coils of wire in which the current is induced. The electromagnet is rotated by a turbine, which itself can be rotated by multiple means such as steam or wind. Without Faraday's law, we simply would not have most of the technology that we rely on daily.